All right. Good afternoon, everyone. We got a couple people in here right now. We're just gonna wait like only 1 or 2 minutes today, and then we're gonna go over the culminating assignment. But hope you guys have been doing good. If you have any questions right now, you can ask me as well. I'd be happy to answer any questions that you have. Hello, Matten. Good to see you. Sorry didn't respond to you. I was just writing an email real quick. All right. I think we're just going to get right into it. I'm going to try to add my webcam to this so that it's easier to think or easier to see. So give me 1 second as I set that up. And I think that is good. Okay. So the main thing we're going to be doing, your culminating assignment will be posted very shortly at 2 p.m. So let's talk about what it is. So this assignment is essentially just talking about the 17 equations that change the world. So we're going through a variety of different kind of functions and kind of having you explore what kind of functions are there currently in the world, how are they found, and kind of explaining that kind of idea. And so your purpose, once again here, select a topic in mathematics, create a presentation to convey historical background as well as current and future implications in the world. Okay, so you're looking at maybe there are theories or maybe there are actual equations that you're already using for these topics. Now, I don't want people doubling up on topics. So if someone chooses one, you cannot choose that one. So I will have people, I guess, whoever is currently in the chat right now will get first pick. Everyone else will have to just email me and then we'll go from there. So whoever's showing up, you guys get a little bit of a bonus. There's 8 people watching, so you guys will get first pick in your topic and your partner if you choose to work with a partner. So the task given in partners, you will be selecting, researching, and presenting one of the following topics from Ian Stallworth's book, In Pursuit of the Unknown: 17 Equations That Changed the World. It should be around a 6 to 8 minute presentation, which should be around 3 to 4 minutes per member, which is pretty short. And you can use any presentation format. Some examples I gave were PowerPoint, Prezi, video, so on and so forth. So these are the 17 equations, some of which you may know, some of which you may not know. So I kind of wanted to make this make this assignment unique, and thankfully I got this idea from Mr. Nguyen. If you know Mr. Nguyen from before, he was at Newton Brook. I asked him for some suggestions and ideas, and we were able to kind of find this and work on this together. So there are your 17 equations on the screen right now, right? So we have Pythagorean theorem, logarithm, calculus, Newton's law, if you like physics, square root of -1, which is which is an interesting concept, which is about imaginary numbers, Euler's formula for polyhedra, normal distribution, which is statistics, wave equation, which is also physics, Fourier transform, Navier-Stokes equation, Maxwell equations, second law of thermodynamics, relativity, Schrodinger's equation, which is chemistry, and physics, information theory, chaos theory, and then the Black-Scholes equation. So we'll go into a little detail of each one now. So number one, the squaw of the hippopotamus, which is essentially Pythagorean theorem. Where did it come from? Why is it important? What did it lead to? Can you go detail into it? Now, some of you may be like, oh, I want to do that one. It looks so easy. Well, you have to understand this culminating assignment is asking you to explain what it is, how it was made, why is it good, and what more will it do for us in the future. So the easier it is, I find it a little more difficult to make it more interesting and kind of standing out, right? So number two, shortening the proceeding. So this was our logarithmic log we learned yesterday. Log of xy is equal to log x and plus log y. So instead of just, if we have a multiplying of numbers inside a logarithm, we can just add them instead with two separate logarithms. And so y is important, addition is much simpler, and what does it lead to, right? And you can search on into that. Number three, calculus, ghosts of departed quantities. So this is something you would learn in, you have learned, which is the first difference, right? And you'll learn this in calculus as well if you do take calculus. So an introduction to that if you're interested in learning about it and maybe getting a head start. System of the world, Newton's law of gravity, force of gravity of any of an object is determined by this formula of gmm over d squared, where d is the radius between the two bodies. And so there's a pretty simple explanation, but why is that important and how does that help us with maybe space exploration or so on and so forth. So you can go in there. Number five, the square root of -1. We have been saying that we cannot square root -1. However, the letter I represents square root of -1, and so now this is your introduction into something called imaginary numbers. And so I'd be very excited to see what you guys uncover from this and what you guys find interesting about the topic of the imaginary numbers. So it is the category of numbers that's it's grouped under. So we have real numbers, natural numbers, rational numbers, integers, right? Those are all groups of numbers, and the group of numbers that we don't really use in your course is called complex numbers. And so complex numbers would be talking about these imaginary numbers. So that is definitely something you can look into as well. Okay. Number six, Euler's formula. It's not Euler, it's Euler. So Euler's formula for polyhedra. So when it's talking about polyhedra, we're talking about polyhedron, right? So shapes of faces and shapes of 3D objects, and the rule that it always follows. And so this seems very simple once again, but it's very interesting how it works out, especially when we start designing and kind of talking about geometric properties of various surfaces, as well as even going into DNA. And then it says here going into celestial bodies. It's pretty crazy. Like everything in the world that has a 3D shape follows this rule. And you can go dive into various different ideas about this topic here. Number seven, normal distribution, the patterns of chance. If you've ever heard the term bell curve, if you ever heard that term, this is what it follows. That's called a normal distribution. And if you're going into statistics or even economics, I highly suggest taking a look at the normal distribution. This is a very interesting topic as well. Something that really seems very like surface level can actually go very deep into explaining various different concepts. Number 8, the wave equation. So this is technically using derivatives of calculus, but you do not need to know that. You're not going into the details of calculus, but we're talking about waves here, right? So we're looking in respect to space, the distance it travels, as well as the speed of the wave. So if you want to dive into that, I highly suggest trying the wave equation. Fourier transform, integrals, so higher level calculus here. But the Fourier transform is very, very unique, and it's actually widely used. So it's a concept that I've learned in university. Obviously, I'm not asking you to explain perfectly what it is, but why is it important? What can it do, and what can it do for us in the future? Like, there's a lot of things that you can uncover that actually use this function and this integral, which might be very surprising for you with Fourier transform. The Navier-Stokes equation. This one is actually very unique, and it is technically using Newton's law, but I personally have not used this equation myself, so it was very interesting to know that this is Newton's law written differently. And so I found it very interesting, and you'll notice that it leads to a lot of kind of inventions that use movement. So high-speed movement, such as it says there, Formula 1 racing cars, passenger jets, submarines. Like, there's a lot of different aspects that can be kind of connected to Newton's second law, and so that's a very interesting kind of thing here. And I think the really unique part about this is that Newton's second law is just that all laws, net force will be zero as long as you have equal forces on one side, on each side, so on and so forth. Where there's a force, there's a mass, there's an acceleration. But this is interesting because it uses density and it uses pressure, change in pressure. So that's usually not something you see in Newton's law, and it's not really included. So definitely interesting to dive in there. Maxwell equations. This is something I have done before. This is chemistry, specifically in the idea chemistry and physics is in E&M, which is electricity and magnetism. So when you talk about things being magnetized or charges going through, this is definitely the one you often use in later on courses. Second law of thermodynamics. This here, if you can explain this, I will be like impressed. The second law of thermodynamics is very simple. The change in entropy is greater than or equal to 0. It will never be less than 0. And that's really interesting. You have to define what entropy is. And if you've taken chemistry, you may have heard it, grade 12 chemistry, you may have heard the term of entropy, but you probably don't fully grasp what it is. I personally didn't even fully grasp entropy until like third year university. It's not an easy concept, but I'll be very impressed if you can do it. And it's actually explains a lot of what happens within the universe. Like, things that you think and you do in regular life always falls under this category of entropy. It's very interesting. So this is actually a chemistry and physics concept put together. So I highly suggest taking a look at this as well. This is the theory of relativity, the equation that everyone states to be, oh, I'm a genius, I know E equals mc squared. Often quoted equation of energy is equal to mass times the speed of light squared. And what is this? What is this supposed to mean? And what did it even lead to, right? So we say it all the time, but now you're going to be diving into the theory of relativity and what does it have to do with this. And relativity, we're talking about things that move as close to the speed of light. So we're no longer, anything that travels at the speed of light or close to that, like 99% the speed of light, will no longer follow proper physics laws. And things start breaking apart. And that's why we have relativity laws that keep them together and understanding that. So this is very interesting as well. A little tougher, in my opinion, because you have to understand relativity and research that, but very interesting topic nonetheless. Number 14, Schrodinger's equation. This is quantum mechanics for chemistry and physics. specifically about waves, right? So when we talk about quantum chemistry, you'll often hear about Schrodinger's equation in the future. This is definitely a very interesting concept with understanding the difference between wave particles and waves and particles. So this is like the fundamental basic of quantum mechanics if you want to dive into that. Number 15, codes, communications, and computers. So information theory. So we have probability. So this uses statistics, and we're diving into kind of communication through coding and how does that work, especially when you see the sum of and you have probability based into it. And of course, you'll see that it's a base 2 logarithm, and because that's 0 and 1. And we use 0 and 1 within communications within computers and technology. Number 16, the chaos theory. So population size of the next generation is equal to whatever the growth rate is of the population size from then until now. Pretty interesting. Population changes from one generation to another. And you can kind of identify that this doesn't always, like when we talk about population, a lot of people think about human beings and like animals, but that doesn't always have to be the case. When we talk about population changes, that could be anything in the universe. Celestial bodies, number of stars, black holes, could be a lot of stuff. And so you can dive a lot into it. Even weather is a part of population. And like the word population is very dumbed down to the point where it only has to talk about physical human beings, physical animals, but it doesn't. And so that's pretty interesting there with chaos theory. And number 17, so the Midas formula, the Black-Scholes equation we have here. So we're talking about rate of change and specifically about economy, essentially, right? So we're talking about economy, changes in economy, and are we looking to make proper things that can calculate and identify changes within the economy. So pretty interesting there, especially if you're interested in learning more about money. Maybe you dive into something that talks about how to make more money, stuff like that. Definitely a topic you can look at. So title page, and so your presentation, are you actually presenting to me? No. If you would like to do that, we can set up a Google Meets to do that. Absolutely, that'd be fantastic. But essentially you're just creating something for me to watch and look at. If you have audio with it, that would be greatly appreciated. But I want a title page. What does it tell us? Why is it important? What did it lead to? And then references in APA format. Okay. So pretty simple. It tells you what the slides are. You shouldn't be passing more than like 20 slides. You can add more to each section if you feel like spreading out the information is better, or you found a lot of like interesting information that you're like, oh, this was really interesting to me. I really want to share what I learned. Then please add more slides, but try not to pass 20. I'd say 20 is like a hard stop where I'm like, okay, now you're going a little too far and you're losing my attention, right? So try to keep it clear and concise, but I'd love to hear what you want to share with me that you found interesting within your discovery of these functions. Layouts. So I'm looking for a design theme, very simple design theme. I don't want something too crazy. Too crazy takes away from your presentation. Simple point form. If you have video clips, add a few video clips to explain stuff. Of course, add images, descriptions, so on and so forth. Make sure you're explaining what you need to do. And your deadline is June 17th. So this will be online for you in around 10 minutes. And if it doesn't, I'll just post it manually myself. And so that's the PowerPoint. That's there for everyone to see. And you'll see a PDF that kind of has it more laid out in a nice, more clear and concise form. And so you can do that as well. So that being said, I don't have to share that screen anymore. Does anyone have any questions on what the culminating was, or questions about the lessons from previous days? If not, please type in the chat or email me right now. Email me right now. This is my partner and this is the topic we want to do, right? So You guys have first pick. We have 11 people watching right now. You guys have first pick. What topic do you want? Who's your partner? And you have to email that or tell it to, or tell me in the chat right now, so that I can kind of create that. Actually, I might even just post a Google Drive Excel sheet, a spreadsheet, and then you guys can even edit it, or maybe tell me there and I'll input it there. Okay. So we have. If you don't have a partner, that's okay. You can work alone, and of course, so I see Iram and Matten have already picked their numbers. Matten, do you have a partner that you want to work with? And Iram, you said normal distribution. Yes, you can work alone. So let me just write that in right now on my spreadsheet here. So we have Iram. And so that'll be number 7. Very good. No partner. Jules wants to do second law for thermodynamics. Yes, you can. Do you have a partner? Matten wanted number 1. So Jules, Crystal, if you don't have a partner, just pick a function, and you're good. Matten, do you have a partner? And Jules, we're good. I have you written down, so you are free to start working on that as well. Yeah, no problem. For those of you who have, so Jules, Iram, you guys can head off. You guys don't need to stay if you don't have any questions about lessons. You guys can head off and do your own thing. Thank you so much for tuning in, and I'll see you tomorrow, 2 o'clock, for your lesson. The 17 functions, Julia, got it. June, you forgot what the 17 functions are. I can bring it up on my screen right now. I'll also post it on Google Classroom right now so that you have it. Give me 1 moment, please. So you should see it on your Google Classroom now, but I'll bring up the 12 here, or 17 here. So here are the 17 functions. Hopefully you can read it, June, and just tell me what you would like for me to pick out of these, or you would like to pick out of these, so I can write it down. So Julia and Iram, you guys are good once again, so you guys are good to go. Yes, please email me, Matten. I already wrote you down for number 1, so take care, Matten. Just email me your partner, and I'll write it down in my spreadsheet. Awesome. Take care, Matten. So this is on Google Classroom now, so you should have it. So I'm gonna switch back to my webcam so I can communicate a little better. All right. Does anyone else have anything? If not, just email me. I do have a staff meeting at 2 o'clock, so I will have to shut this down very soon. So I'll give you guys a minute or so to respond, and then I'm going to have to shut down the live stream. Olivia is going to do number 4. Olivia, will you have a partner? No partner, okay. June will do relativity, number 13. Would you like, well, are you going to have a partner, June, or will you be working alone as well? All right, and so I think, Azar, I need, you didn't send in what number you wanted to do. Azar, what number? Eight, got it. Azar, you're good to go. Yes, June, you can send an email later if you want to pick your partner, and then let me know. Awesome. Thank you everyone for responding. Crystal is number 7, and if once again, if you have a partner that you want to talk about later or email me about later, yes, that'll be fine. Okay. So I'm probably going to only have a maximum of 2 groups per each number. So number 7 is done. Iram and Crystal are doing number 7. And that's done. Okay. So take care, everyone. Have a good rest of the day. Hope you enjoy kind of researching about the culminating, but we will be continuing our logarithmic function lessons tomorrow at 2 p.m. So I'll see you then. Peace out.